Hey class, how are you? Math enrichment here. Yay. Have a good day. And seems like everything's going well today. Just want to give you guys a quick video on how to do, there's some tricky points on standard scientific notation and bringing it into standard form and back. Okay, so I want to give you that little tricky spot and try to harp on that and focus that to make sure everybody gets the understanding of scientific notation. All right. So we talked about before that scientific notation, again, positive, where we have a positive value right here. Basically, we're going to add zeros to the right of the expression. If we have negative values, then we're going to add zeros to the left. Okay. So I think we got that idea down from what I saw on Friday. Okay. Now the issues become, okay, looking at this, we have 4.5 to, 45.68 times 10 to the power of 5. Okay, so we talked about that yesterday, basically saying, okay, yeah, we have 10 to the power of 5, so we take this decimal point and we move it 1, 2, 3, 4, 5 spots. We add some zeros and we're done for the day. But, however, unfortunately, scientific notation is actually not represented this way, okay, in the expression. So it's always, the rule is that the decimal point is always going to be between the first two numbers in that expression. Okay. So it's actually technically should be between the 4.5. Okay. So, it should be 4.5, not 45.68. So what happens is you have to actually move this decimal one space over to the left. Therefore, meaning that by doing that, you're adding 1 to the exponent. Okay? So remember that. That's going to be very critical when we start to do with the law of exponents work is this information. You got to have this information. Okay? So again, it's going to be rewritten as this. 4, okay? I can read this quickly. Wish we can go fast. Don't have pixel control, whatever they call it. Okay, 8 times 10 to the 6th. Okay? So again, that's how it actually should be written. That's the official way. Okay? 4.568, 10 to the 6th. So again, got to move the decimal place over one space to the left. It has to be between the first two numbers in the series. Okay? And then, like I said, basically from there, you have to add 1 to the expression. The exponent. Okay, so let's look at the next one. So we have a negative number. So again, this one is also kind of tricky because we're actually going to the left. But if you think about it, the same rule applies. So again, if we have this at 24.7 times 10 to the power 6, we said yesterday, Friday, okay, just move it over 6 spaces to the left. And that's we call it a day. But again, we want the decimal to be between the 2 and the 4, which are the first two numbers in the expression. Then we have to move with those spots. So once we do that, we have to, again, like I said, we have to add 1 to the negative 6. This is where our positive negative integers work can come in. Okay, so that would give us negative 5. Okay, so therefore, our new equation is going to look like this. 2.4 7, okay, times 10 to the negative 5. Okay, and that's how it should look, right? 2.47 to 10 to the negative 5 when we add 1. Okay, so people are like, what the heck? I can't see that. What are you talking about, Mr. Gray? This is crazy. Okay, so again, what I'm saying is if we started here at this point, if we started at, let me do this out. Let me do 0.7. So if we do 10 to the power of 6, basically we're going to add 4 zeros here. Okay, and if we do our math out, boom, 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 we go 6 spaces. Well, technically, scientific notation has to be between the first two numbers. So basically, we're saying that it has to be. Come on, baby, come on, make the 2. There you go. Oh, that's getting crazy on me. And so basically, if we start at the 2, 4, 7, like we're supposed to, we add those zeros, we'll still have the same amount of zeros. And again, we'll still have the same amount of zeros. 1, 2, 3, 4, 5. Okay, so that's how it would work in that situation. That's the difference. Okay, right there between that and that. That's what we want to do. So again, just make sure you get that information. That scientific notation always has to be between the first two numbers, and then we add 1 to the exponent, and you should be good. Okay. Now let's show this how this really makes a difference. Okay, in problems that we're going to be doing. Okay. So here's a couple of questions I have here. I have 4.9 times 10 to the power negative 3 times 2.8 times 10 to the power 2. Okay. So the easiest way to work this is we don't want to make this into, we could 4.9 times 10 to the negative 3, find out what that number is, then multiply 2.8 times 10 to the power 2 and take that number is, and then put in the standard scientific notation. You could do that if you wanted to. So that is a way, this is a viable option. Okay. But the easiest way is to multiply your numbers and multiply your exponents. Okay. Use the multiplication rule of your exponents. It makes it easier to do the work. So basically what I'll do is I'll multiply 4.9 times 2.8, and I'll multiply 10 to the power 3 times 10 to the power 2. So if I did that math out, I'm basically going to get a situation of 13.72. Okay. And then we did, remember, multiplication rule, MR, right, and R here, basically tells me that negative 3, remember, the multiplication rule is basically adding the exponents together. So that gives us 10 to the, that would give us 1. Okay? So basically, that would be 10 to the power of 1 when I do that out. So let me do that right here. So this would be 10 times 10 to the power of 1. Okay, so that should be the answer to the question, right? Just doing it that way. That's the right answer, right? Wrong. That is not the right answer. Okay. So again, remember we want to make sure it's got to be, the decimal place has to be between the 1 and the 3, not the 1372. So on the test, if you do that on a quiz, you're going to be wrong. Okay. So this has to move one space to the left. Well, therefore, the real answer should be, put a little move over there. It should be 1.3 2 times 10 to the power of 2. That should be the real answer to the question. All right. So again, got to make sure you watch that. That's very critical. You know what I mean? So you start to see what I'm saying here. So make sure that you're able to watch that when we start to do these problems in this work today. Okay. So let's look at the next one here. Same thing. We have 40. So we should know what we need to be doing. Basically, we got to multiply our numbers and then use the multiplication rule on our exponents. So we have 49. 7 times 7 is 49. That's easy. Hopefully. Okay. And the other portion we have negative MR, using the MR rule again. Okay. And that's negative 3 plus 0, which is negative 3. So same situation, 10 times negative 3. Oh, shoot. But look at it. Now we have 49, though. So again, we got to, so basically, remember the decimal point should be right here if it's 49. So we got to get it in between the two numbers. So we got to move it one space over. So again, our new answer should be, because we got to add 1 to that, is 4.9 times 10 to the negative 2. Okay, make sure you see that on the problems here. Make sure you're able to do that. Okay, so again, make sure, I keep saying make sure. I don't know why I keep saying that, but I think we get the idea of what we need to do. Hopefully, you can do that on the questions that we have, and then also you're able to do that on the in class as well. All right. Thank you, guys.